Hello everyone, this is Aparna Shetty, Assistant Professor, Department of CSE, AJ Institute of Engineering and Technology. So in the last video, we had studied about packages, correct? Module 4, we had studied about packages. In this video lecture, let us study about interfaces, which is module 4 in the subject object-oriented concepts. So let us begin. Okay, using interface, we can specify what a class must do, but not how it does it. Okay, so this is very important. Interface allows you to specify what a class must do, but does not specify how that class must do it. Interfaces are syntactically similar to classes, but they lack instance variables and their methods are declared without any body. So just like how we define classes, we have interfaces, but there is no instance variables in interfaces, and also the methods that are defined or declared inside an interface do not have a body. So we just have method declaration, okay, inside an interface. We do not define the method, just we declare the methods. So that is what an interface consists of. Once it is defined, any number of classes can implement an interface. So once we define an interface, any number of classes can implement that interface. Also, one class can implement any number of interface. So one class can implement two or more interfaces. To implement an interface, a class must create the complete set of methods defined by the interface. So when a class wants to implement an interface, that particular class must provide the definition of all the methods within that interface. Okay, so if it is going to implement an interface, it should define all the methods of an interface. Okay, that is compulsory. Interfaces disconnect the definition of a method or set of methods from the inheritance hierarchy. Since interfaces are in a different hierarchy from classes, it is possible for classes that are unrelated in terms of the class hierarchy to implement the same interface. So hierarchy of classes is different from the hierarchy of interfaces. Okay, so even though the two class is unrelated, okay, they do not belong to the same class hierarchy, or two unrelated classes, you can connect them by using the same interface. That is the meaning of this statement. This is where the real power of interface is realized. So the real power of interface is providing a connection between two or more classes. Defining an interface. So this is the general form for defining an interface. Okay, access, interface name. Then we provide the method declaration, return type, method name, parameter list ended with the semicolon. This is the method declaration. Okay, as I already told you, we only provide the method declaration within an interface, right? And see here, within this interface does not have these interface define final variables. Okay, we can only declare final variable within an interface. Type final variable is equal to value. Okay, so the variables that are declared inside an interface, they are called as final variables. Now, what is the meaning of final variables? Is that the method that is going to implement this interface, it cannot change the value of the variable. So the variables that are declared within an interface are called as final variables because the implementing methods cannot change the value that is initialized to that variable. Okay, so and also the value has to be initialized when declaring the variable itself. Okay, so this is an general form of an interface with the method declarations, okay, and the variable declaration. The variables are called as final variables because the implementing methods cannot change this value that is assigned to the variable. Okay, and also the implementing classes needs to provide the definition of this method. The interface just has the method declaration. So this is the general form of how we are going to define an interface. When no access specifier is included, then the default access results and the interface is only available to other members of the package in which it is declared. So in the previous lecture, we have seen about the default access modifier, right? If you do not specify any access modifier, then it results in default access. That is, that particular method is only accessed within the same package. So default access modifier means it is only accessible within the same package, right? That is what they are telling here. When no access specifier is included, then default access results and the interface is only available to other members of the package in which it is declared. When it is declared as public, the interface can be used by any other code. Notice that the methods that are declared have no bodies. Alright, we saw the interface declaration, that is the general form. We saw it here, right? You can see here we just declare the methods and these methods do not have any body. They end with a semicolon after the parameter list. They are essentially abstract methods. There can be no default implementation of any method specified within an interface. And also these methods are called as abstract methods because they do not have a body. Correct? We just declare the methods inside an interface, and also you cannot provide any default implementation of the method also. Okay? That you have to remember. That is why they are called as abstract method, because we cannot provide even the default implementation of the method within an interface. Each class that includes an interface must implement all the methods. This is one more point that you have to remember. Okay, a class that is going to use an interface should implement all the methods that are declared within the interface. Variables can be declared inside of interface declaration. As we have seen, we also have variables within an interface, right? These are implicitly final and static, meaning they cannot be changed by the implementing class. As I already told you, the variables are final and static variables because the value of the variable cannot be changed by the implementing classes. So final variable means you cannot change the value of that variable. They must also be initialized. You have to remember that whenever you are going to declare a variable in an interface, you are supposed to initialize that variable also. All the methods and variables within an interface are implicitly public. Let us look at the example here. See this interface, the keyword interface, followed by the name of the interface, callback. Within this is a simple interface where I have just one method declaration. Okay, that is, I have declared the callback method over here. This method does not return any value, nor it just takes one parameter which is of type integer. So this is the method declaration within an interface callback. See here, this is the method declaration. There is no body of the method defined. Okay, just the method has been declared within the interface callback. Now the class that is going to implement this callback interface is supposed to provide the definition for this method. Next, implementing interface. Once an interface has been defined, one or more classes can implement that interface, right? As we have already seen, once we define an interface, two or more classes can implement that interface. And also those classes should implement all the methods of that interface. To implement an interface, include the implements clause in the class definition and then create the methods defined by the interface. So the class that is going to implement an interface should include the clause implements in its definition and then create the methods defined by the interface. So let us see how the class is going to implement the interface by using the implements clause. The general form of a class that includes the implements clause looks like this. Class, class name. Suppose if you are creating a class hierarchy, suppose if this class is a subclass, then you need to write extends superclass. Okay, that is only if the class is a subclass of any other class, then you need to use the keyword extends and the superclass name, then the keyword implements, okay, and the set of interfaces that this class is going to implement. So one class can implement two or more interfaces. So implements, if there are more than one interface, okay, then you have to separate it by a comma. Okay, so if there is only one interface, you just have to provide one interface name. If there is more than one interface that this class is going to implement, then include those interfaces separated by a comma. Okay, so this is the general form of how a class looks like that is going to implement the interface. Class, class name, the clause implements, the name of the interface. Okay, if there is more than one interface, you have to separate it by a comma. And also if this class is a subclass of any class, then extends superclass. If it is not a subclass of any class, then you need not include this extend superclass. Okay, so this is the general form of a class that is going to implement the interface. If a class implements more than one interface, the interfaces are separated with a comma. The methods that implement an interface must be declared public. Okay, the implementing method should be declared as public. Also, the type signature of the implementing method must match exactly the type specified in the interface definition. So the return type and the parameter list of the implementing method should be exactly the same as the return type and the parameter list specified for that method in the interface definition. Example, look at this example here. Okay, we had seen that callback interface definition, right? In the previous slides we have seen the defining that callback interface. Now that interface had just one method, right? It had provided the declaration of just one method, that is callback method, okay, which does not return any type. It takes just one integer parameter int p. Now this class client implements callback. So client is the class that is going to implement the callback interface. Okay, now as we have already told, the implementing method should be public. Okay, so the implementing method should be public. So that is why this is the implementing method. It has to be public, and also the type signature of the implementing method should match exactly the same as the type signature of the method defined in the callback interface. Okay, let us see that once here. See here, this is the method that was declared inside this callback interface. The type signature of this method should match exactly the same as the implementing method's type signature, right? So the implementing method and the method declared inside the callback interface should be exactly the same. Its type signature should be exactly the same, and also the implementing method should be of type public. Okay, here we have implemented this callback method. Just we are going to display callback called with p. So p is the parameter that is passed to this method. We are just going to display callback called with, that is the parameter value we are going to append. So this is the class client that is going to implement the callback interface. Okay, it is going to provide the definition of the method in that callback interface. So this is the method which was declared in that callback interface. Next, when you implement an interface method, it must be declared as public. Okay, otherwise that will give you an error. This is very important. The interface method, when you are trying to implement it, you must declare it as public. It is both permissible and common for classes that implement interfaces to define additional members of their own. Okay, so see here. Now in this client class we have just implemented the method of the interface, right? Now this client class can define its own methods also. So other than the methods of the interface, it can have some other methods also. Okay, you can define other methods also within this class, client class. That is what they are telling here. It is both permissible and common for classes that implement interfaces to define additional members of their own. See here in this example, that is the same client class implements callback interface. Okay, here we have provided the definition of the callback method, which is the method of the interface, correct? Okay, and here we have one more extra method, that is non-iphase method. Okay, this is the other method that has been defined by the class client. So here class client is going to implement a method of the interface, that is callback method. Also it can have its own method definition. So non-iphase is a method of the client class. Okay, so this is the non-interface method. So inside the callback method, we will be displaying callback called with, okay, appending the parameter that is passed. Non-iPhase method here does not have any return type, nor does it take any parameter. It is just going to display classes that implement interface, okay, append it with one more string, may also define other members too. Okay, so it is going to display this statement telling that the classes that implement interface may also define other members too. So this is an example where the class client will implement a method of the interface as well as it can define its own methods. Okay. Now, next topic, accessing implementation through interface references. You can declare variables as object references that use an interface rather than a class type. This statement now you will better understand it when I give an example. Any instance of any class that implements the declared interface can be referred to by such a variable. So, the following example calls the callback method through an interface reference variable. Let us see how this example works. Now see here, class test iPhase. Okay, inside this class test iPhase, I am going to define the main method. Okay, now in the main method here, new client will return me a reference to the client class. Correct? It will return me a reference to the client class. Now that reference will be assigned to C, okay, where C is a variable of type callback interface. Okay, this is what they were trying to tell in the previous slide. Okay, now the client variable, okay, can also be represented by an interface variable C over here. Okay, again see here, again I will explain it. New of client. Okay, here what we are doing, new will dynamically allocate the memory for the class client and it will return a reference to client class. That reference is assigned to the callback interface variable C. Next statement C here, C dot callback of 42. Okay, here using this variable, interface variable C, I'm calling the callback method. Correct? The callback is a method of the interface which had been defined by client class. Okay, or callback is a method of the interface which has been implemented by the client class. Now we are calling this callback method using the interface variable C. Okay, and we are passing the parameter 42 over here. So the following example calls the callback method through an interface reference variable. Now this program will be successfully executed. You can always call a interface method by using the interface reference variable. Okay, now the object of the client class that implemented the interface, you can represent it by the interface variable C. So the output of this program will be callback called with the 42. We have seen this callback method. Yes, it will just it will take that P as a parameter. So the value in P will be 42. So it will just display callback called with the 42. Okay, so it will just display callback called with the P, that value of P is 42. So callback called with 42. See this callback method here. Callback method callback called with p. So it will just display this statement. Okay. Notice that the variable c is declared to be of the interface type callback, yet it was assigned an instance of client. Okay, this is also possible. Okay, here the callback variable, the interface type callback, okay, variable c, it was assigned an instance of client class. Although C can be used to access the callback method, it cannot access any other members of the client class. Now here, this variable C, okay, a variable C you are using to access the callback method, right? But now the same interface variable C cannot be used to access the other methods. Okay, if I tell other members, the other methods of the client class. So the other methods of the client class I cannot access by using the interface variable C. Okay, this interface variable C, you can use it to access the callback method, because callback is a method which was declared by that particular interface, right? Callback was the method that was declared by that particular interface. That is why by using the interface variable I can access that method. But using this interface variable C, I cannot access the other remaining methods of the client class. Okay, the client class can implement several other methods of its own also. Those methods I cannot access by using this instance variable C. An interface reference variable only has knowledge of the methods declared by its interface declaration. Okay, so that using that interface reference variable, you can only access the methods declared by the interface declaration. That is the meaning of this statement. Thus, C could not be used to access the non-iface method, since it is defined by client but not by callback. Here, non-iface method is a method that is defined by the client class. Okay, this method was not declared by the interface callback. So, using C, I cannot access the non-iface method, since it is defined by the client class but not by callback interface. Another implementation of callback. Let us see how this implement works. There is this class, another client, which also implements the same interface callback. We have already seen, right? One class, the same interface can be implemented by two or more classes, correct? So this callback interface can be implemented by any number of classes. So this is another class. Okay, that the name of the class is another client, which is going to implement the interface callback. See, this class can have its own implementation for the callback method. So another client class can implement the callback method of the interface in its own way. As we have already told, the implementing method should be public, and also the type signature of this callback method should be exactly the same as how it is declared in the interface. So this is what this method does. It will just display another version of callback, and next it will display p squared is p into p. So what parameter you pass here, the parameter p that is passed here, okay, it will just display its square, that is p squared is p into p. Okay, suppose if 2 is passed here, then it will display p square is the value of 2 into 2. What is the value of 2 into 2? 4. That it will display. So this is one more implementation of the callback method provided by the another client class, which is going to implement the callback interface. See this one more main method now. They have defined the test IFACE method. Okay, this is one more class which is defined the main method. Inside this main method, first I am going to create an object of class client. We have already seen the client class implementation in the previous slides, correct? If you would have written it down, it would have been better so that you can understand it clearly. So please write down those programs. So as I have already told, here you are creating an object of the client class. Now that object you are going to assign it to a callback variable C. So here C is of type interface, that is callback. Now I call C dot callback of 42, that is I am calling the callback method in the client class with the instance variable. C is an instance variable dot callback. If I pass the value 42, okay, so the callback method will get executed. Okay. Next what I'm doing is, see this statement over here, another client object is equal to new another client. Now what I'm doing is, here I'm creating an object OB. This object is of class type another client. So another client is the another class that is going to implement the callback interface as well. So OB is an object, okay, representing the another client class. Now over here if you see that object, that is another client class object, I am assigning it to C. Now OB is an object of another client class. What is C? C is of type interface, correct? C is of type callback interface. Now C now refers to another client object. So I can call C dot callback of 42. So it will call the callback method of another client class. Okay, this callback will call the callback of client class. Okay, here you are going to call the callback method of the client class, right? So it will call the callback method in the client class. Okay, because here C you have assigned it an object of client class. Now OB is an object of another client class. That OB you have assigned it to C. So C now refers to another client object. So C dot callback over here will call the callback method of another client class. So it will call the callback method of another client class. Okay, so that is how this program executes. So this was one more implementation of main method, where you are going to call the callback method of the client class, as well as you are going to call the callback method of another client class. So the output from this program is shown here. So in this statement over here, when you call the callback method of the client class, it will display callback called with P, that is callback called with 42. Here when you call the callback method of another client class, it will display another version of callback. Okay, P squared is 1764. 1764 is nothing but 42 into 42. 42 into 42. So another version of callback, p squared is p into p. Okay, so this is the output generated from the callback method with client class. Right, and this whole thing is the output generated from another client class, right? Okay, so this is the output of the particular program test iphase2 when you execute. As you can see, the version of callback that is called is determined by the type of object that C refers to at runtime. Based on the type of object that C is referring, okay, based on the type of object that C refers to, that particular version of callback method will be called. Next topic, partial implementations. If a class includes an interface but does not fully implement the methods defined by that interface, then that class must be declared as abstract. So if the class is not going to fully implement the methods defined by that interface, then the class must be declared as an abstract class. Example here, see this class, class incomplete implements callback. Okay, so here inside this class we have declared two variables a and b, and we have this show method, correct, which is going to display the value of a and b. Now even though this class implements callback, it has not implemented the callback method of the callback interface, right? It has not implemented the callback method, right? That callback int p. This method it has not implemented. So that is why the class that is not going to implement the interface fully, that is, it is not going to implement all the methods of the interface, then you must declare this class as abstract. Okay, so a class which does not implement the interface fully must be declared as abstract. Okay, here the class incomplete does not implement callback and must be declared as abstract. Any class that inherits incomplete must implement callback or be declared abstract itself. So any class that is going to the class that is going to inherit the incomplete class, that is, whenever you are going to create a subclass of the class incomplete, so in the subclasses you can implement the callback interface, or that subclass also must be declared as abstract. Okay, so any class that inherits incomplete class must implement callback, or they must be declared as abstract itself. Nested interfaces. Next topic is nested interfaces. An interface can be declared a member of a class or another interface. So within a class you can define an interface, or within one interface you can nest one more interface. Such an interface is called a member interface or a nested interface. So you can call it a member interface or a nested interface. So if you have an interface within a class, if you have an interface as a member of a class, you can call it as a member interface. Okay, you can call it as a member interface. You can call it a member interface if you are going to have an interface within a class. Okay, but if you implement if an interface is nested inside another interface, then you call it as a nested interface. One interface inside another interface is called as a nested interface. So you can nest interfaces as well. A nested interface can be declared as public, private, or protected. When a nested interface is used outside of its enclosing scope, it must be qualified by the name of the class or the interface of which it is a member. Okay, just like how we had nested the classes, and when we use that inner class, we must use it with the fully qualified name, right? Just like that, when the nested interface is used outside of its enclosing scope, it must be qualified by its fully qualified name, or it must be qualified by the name of the class or interface of which it is a member. Thus, outside of the class or interface in which a nested interface is declared, its name must be fully qualified. Example, see this class A. Inside this class A now, we are defined an interface, nested interface. This interface provides the declaration of this method is not negative. This method, just the declaration we have provided because it is an interface. The name of the interface is nested if. So this is the interface that we have declared within a class. So we have enclosed this interface within class A. Okay, in this interface we just have one method declaration, that is the method is not negative, which is going to return a boolean type, and also it takes one parameter of integer. So now class B, which is going to implement the A.nested interface. See here, class B is going to implement this interface, that is nested if. So it implements A.nested if, because nested if has been enclosed within class A. So you have to provide fully qualified name, that is A.nested if. Okay, and in this class B we are going to implement the method is not negative. So when we implement the method, it must be public. Okay, so what this method will do, it will test the value of x here. If x is less than 0, if it is true, it is going to return this value. Okay, x is less than 0. If it is true, it will return this value. X is less than 0 is false, means it will return the value after the colon. Okay, if x is less than 0 is false, means it is going to return this value. So first this condition over here is tested. If the condition is true, the first value before the colon will be returned. If the condition is false, then after the colon what value is there, that value will be returned. So if x value is less than 0, it will return false. If x value is greater than or equal to 0, okay, that is, if this condition is false, it is going to return true. Okay, so this is about the function is not negative. Let's see the main method here. In the main method, first I am creating an object of B. okay, that object will be assigned to NIF. NIF is nothing but a variable of type interface nested if. Here also see, we have to use fully qualified name for the interface. Since nested if is been enclosed by class A, we are supposed to define it like A dot nested if. Okay, so NIF is a variable of the interface nested if. Okay, this variable is representing the object of B now. Now if you call NIF dot is not negative, you pass the value 10. Okay, so what is not negative will return? Is not negative if I pass the value 10, correct? 10 is less than 0 is false, so it will return the value true, correct? So this will return the value true. So if it returns true here, so here if it returns true, that is if of true, then it will display if of true, correct? So this statement will get executed. 10 is not negative, correct? It will just display 10 is not negative. See one more. If over here I call is not negative, NIF dot is not negative, I pass the value minus 12 here. When I pass minus 12 here, minus 12 is less than 0. It is true. If it is true, then it will return false. Okay, so is not negative is going to return false. So if it returns false here, when it is returning false, here if of false, it is going to return false, correct? So it is if of false. If is false, then it will not execute this statement. Only if it is true, it will execute the statement. Here if is false, condition fails. So this statement will not be displayed. Here if was true, correct? So this statement got executed. Here if is false, so this statement will not get executed. Let us see that program. Okay, let us execute and see that program. Nestif demo. Here see the class nestif demo. We already defined it. See here, nestif demo, correct? I have three class. One is class A. It's taking some time. Okay, so I have class A. Then within this class A, I have this interface here, nested if. I have defined the interface within the class A. Then I have class B, which is going to implement the interface. So it is going to implement the is not negative method of that interface. Next I have one more class, nestif demo, which is going to implement the main method. Okay, so now let us execute this program and see how is the output. So the output, it will just display 10 is not negative. Here the condition was false, so this won't be displayed. Okay, so this is how the output looks like for that program. Okay, so let us continue. Notice that A defines a member interface called nested if, and that is declared as public. Next, class B implements the nested interface by specifying implements A dot nested if. Notice that the name is fully qualified by the enclosing class name. Inside the main method, an A dot nested if reference called NIF is created. Okay, NIF is a reference of A dot nested if, and it was assigned a reference to a B object. See here, Here we created a variable of type interface and we assigned it to an object of class B, right? So NIF is a variable which is representing an object of class B. Because B implements a.nestedif, this is legal. Okay, since class B is going to implement that interface, you can use the variable of that interface, okay, to be assigned a reference to the class B object. So class B object, you can represent it by NIF, since B is going to implement the a.nestedif. If B was not going to implement that interface, then you cannot do such assignments. You cannot assign NIF the object of class B. Applying interfaces, fixed stack example now. Now see this interface, int stack. It has two methods, as we have already know now that an interface can just provide the method declaration. So just we have provided the method declaration within this interface int stack. That is, we have declared the push method and we have declared the pop method. So this is an interface int stack. Now see this class fixed stack. This class is going to implement the interface. Okay, class fixed stack implements int stack. So it's supposed to implement the push and the pop method of this interface int stack. Supposed to implement both these methods, that is push as well as it is supposed to implement the pop method of the int stack interface. Okay, so we have this array here, stack array, which is of type integer, and also we have top of stack variable which is going to represent the top of stack. Here we have this constructor. Fixed stack is a constructor of class fixed stack. Now this constructor takes size as a parameter. Next, this stack array, it will allocate that array. So here just we have created a variable, a stack variable, correct, or an array variable we have created. Now in this statement we are allocating memory for that array, correct. Using new operator, dynamically memory will get allocated. How much memory will get allocated? Based on the value of size. Okay, this size will tell you how much memory you have to allocate by using the new operator. So now we have dynamically allocated the memory for the array stack. In this statement we have just declared a variable of type array. Over here in this we are dynamically going to allocate the memory for the array stack. Okay, and we have initialized the top of stack to -1. So this was about the constructor fixed stack. Here a fixed stack was initializing the data of the class fixed stack. Next, see this push method. We are as I told you, we are supposed to implement both these methods, push and pop. Okay, see this implementation of the push method. Implementing method should be public. Type signature should match exactly as in the interface. Here we are testing the top of stack. Okay, top of stack equal to stack length -1. Now here what you have done is, stack is an array, correct. Now suppose if I have given the size 5. Okay, stack stck is an array. Now suppose if the size is given as 5. Okay, so 5 elements can be stored in that stack array, 1 2 3 4 5. Now array indexing will be 0 1 2 3 4. Initially top of stack will be -1. So top of stack will be -1. This is top of stack, right? So top of stack is equal to -1. Now what is the stack length? Stack length is, the length of the stack is 5, right? The length of this stack is 5. Indexing of this stack is from 0 to 4. Length is 5. Now here top of stack equal to stack length -1. Stack length is 5. Okay, 5 minus 1 will be 4. So if top of stack reaches, already it is pointing to this 4. Okay, so if the top of stack is already pointing to 4, that means already the stack is full. Okay, the stack is already full. You cannot insert or push any element to the stack. Okay, so top of stack is equal to stack length -1. Okay, in that case you will display stack is full. Else what you will do? First you have to increment the top of stack. You all know that before pushing an element we have to pre-increment. First increment the top of stack. Initially it will be -1. So first time you are pushing an element means first you have to increment top of stack. So top of stack -1 when you increment, -1 when you increment it becomes 0. So first pre-increment the top of stack and then push the item to the stack. So this was about the push, correct? You all are familiar with stack. First we have to check if the stack is full over here using this condition. If it is full, we cannot push any element. We just display stack is full. Else, first increment the top of stack and then push the item into the stack. Next method that we have to implement of that interface is pop. Push method is over. Next we have to implement the pop method. Let's see this pop method here. Now for pop method we have to test the top of stack less than 0. That is, if the top of stack is -1, okay, top of stack is less than 0, in that case there are no elements in that stack. We will display stack underflow. Okay, because there are no elements in that stack. If top of stack is -1 or less than 0, we will display stack underflow and we will return 0. Else what we will do? Return top stack of top of stack. So the top element you will return, and it is post decrement here. Once you pop the top element, after that you are supposed to decrement the top of stack, right? So that was about the push and the pop methods. Now we have implemented this main method. See, main method inside the class if test. Now in this main method, created two objects of type fixed stack. Okay, so we are passing 5 and 8 here. That means my stack 1 will have 5 elements, right? My stack 1 will have 5 elements and my stack 2 will have 8 elements. So there will be 5 elements in my stack 1 and 8 elements in my stack 2. Okay. Next, we are going to push the elements to my stack 1. So here there has to be 5 elements. So int I is equal to 0, I less than 5, I plus plus. My stack 1 dot push of I. You are going to push 0, 1, 2, 3, 4, right? Here you are going to push 0, sorry. 0, 1, 2, 3, 4. Okay, these are the elements that are going to be pushed to my stack 1. Next, we are going to push the elements to my stack 2. So we are going to push 0, 1, 2, 3, 4, 5, 6 and 7. These are the elements that are going to be pushed to my stack 2. Next, we are going to pop those elements of the stack. So stack in my stack 1, again whenever we are accessing arrays, we need to have a for loop. So for int I is equal to 0, I less than pi, I plus plus. Here you will pop the elements of my stack 1. Okay, so it will pop these particular elements will get displayed. It will pop the element over here and it will display it. Same way, display the elements of my stack 2. Here using this for loop, you will pop the element and you will display it. So this is how the main method is implemented. So now let us look how that program executes. Okay, so see this if test over here. Okay, so this fixed first we had this interface, right? This I represents interface. Int stack was this interface. You had this interface. Next we have this fixed stack class which is going to implement the interface int stack. That is, it is going to implement the push method and the pop method. And we had this if test class where we have written the main method, where we are creating objects of fixed stack class. We are pushing the elements to the stack and we are popping and displaying the elements of the stack. So let us execute this program and see how the output looks like. See here it is going to pop and display the elements, right? So the elements of my stack 1 are 4, 3, 2, 1, 0, right? So the stack in my stack 2, the elements of my stack 2 are 7, 6, 5, 4, 3, 2, 1, 0. So this was how this program got executed. Let us continue now. Interfaces can be extended too. Okay, here they are telling we can extend interfaces. One interface can inherit another by use of the keywords extends. The syntax is the same as for inheriting classes. Just like how we inherit the class, we can inherit the interfaces also. When a class implements an interface that inherits another interface, it must provide the implementation for all the methods defined within the interface inheritance chain. So, when you extend interfaces, the implementing class must implement all the methods in that interface hierarchy. Okay, so class implementing an interface that inherits another interface. So now this class is supposed to implement all the methods of the interface and its inherited interface also. See here, we have this interface A which with the two methods, meth1 and meth2. We have one more interface B which extends A. So B is inherited from the interface A and it just has one method, that is meth3. Okay, so B now includes meth1, meth2 as well as meth3. Okay, this inherited interface will have the methods of its super interface also. So since B is going to inherit A, B can have the members of A also, which is the members of A, meth1 and meth2. Now see the class my class. The name of the class is my class. It implements the interface B. Now since B is going to inherit A, now the implementing class should implement all the methods of B and A also. So my class has to implement the methods of interface B as well as it has to implement the methods of A also, because B is inheriting the interface A. So here if you see, we have provided the definition of meth1, meth2 and meth3. So all the methods of A as well as B are implemented here. It has to be public. Here it will display the statements telling implement meth1. In meth2 it will display implement meth2, and in meth3 it will display implement meth3. See this class ifExtend, which has the main method. Here we are creating an object of my class, and using that object we are going to call meth1, meth2 and meth3. We'll see how this program executes. See ifExtend here. It is here. Okay, ifExtend. So just I'll close this previous programs. So I have initially interface A, then I have interface B, then I have this my class which is going to implement B as well as A, all the methods of B and A. Then I have ifExtend, right? Here we have the main method which will create an object of my class and call all the methods of my class. Let us run this program and see. So it will display all the statements: implement meth1, implement meth2, implement meth3. So this is how the output looks like. Okay, let us continue. So that was about today's class. Thank you. I hope you are clear with all the concepts. If there is any doubt with any concepts, we can discuss it in the Google Classroom. So thank you.